Good day, my students. I welcome you back to Eko Learners Support for WAEC and NECO candidates. My name is Joseph. I'm your instructor for today's class. Let's sit back and enjoy ourselves together as we dive into today's class.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Are you ready for today's class? That is what I have there. I hope you are ready. If you are ready, let's dive in. What are we going to be doing today? We need to know what we are going to be doing today. On that note, our objective will be sources of oxygen. Where do you think we can get oxygen from? Explain why oxygen. We need oxygen. Then explain preparation of what? Oxygen. So these are things that we're going to be doing. So be moving with me as we continue the class. Yeah, basically, we all know that oxygen is what? Is a gas, no matter. You agree with me? Fine. Therefore, most of the gases in air are essential to us. But oxygen is more essential. Because without oxygen, we cannot breathe in. Respiration will not occur. And when there's no respiration, how will the food broken down to give you what you need? Energy. You won't be able to do that. Okay, fine. Therefore, without nitrogen to dilute the oxygen too, there may be a problem because most of the metals will get rust and we need to be changing them often. With that, we'll be wasting our money. Okay, fine. But the gas depend on most is oxygen. So the gas that will depend most is oxygen. Without it, it might be so difficult for us to live. I've explained that. So we need it for different what? Reaction. One of the reaction is what? Respiration. As you know, the glucose need what? Oxygen. The oxygen will break down the glucose to give you carbon dioxide, water, and energy. To let you know that without what? Oxygen, you might not be able to live. The energy from respiration keeps us warm. Not only that, allow us to move. Without energy, can you move? I doubt. Enable what? Hundreds of different reactions to go on in our bodies. Good. For example, I've told you, respiration and other things. So without it, there may be what? Difficulties. Not only that, you remember fish? Yes, in their aquatic what? Habitat, they too need what? Oxygen to move on with the life. The oxygen might not be the dry one, but dissolved oxygen. Basically, they need it. To let you know that oxygen is very, very important when it comes to what? Life. So oxygen is the most abundant element on Earth. You need to know that it's the most abundant element. And this oxygen, you need to know as well, that belongs to what? Group 6 of the periodic table. Why do we say oxygen belongs to what? Group 6 in the periodic table? I hope you know the valence electron actually determine the group with the words element belong to. So oxygen is 8. So if we go with what? 2. First share is taking maximum of 2. The second one, because 6 is left, so I get it 6. 1, 2, 3, 4, 5, 6, 7, 8. So this is the valence what? Shell. Why these are the valence electron? So when you count the valence electron, how many electrons do you see there? You discover that the electron is what? 6. So oxygen belongs to what? Group 6. Not only oxygen we have in that group, we have sulfur, not only sulfur, selenium, yes, tellurium, these are, and what? Polonium, yeah, these are the words, other members of what? Group C's elements. I hope you are following me. Good. There's an increase in metallic property, yeah, from oxygen down to what? Yes, polonium. You know, when they say metallic property, ability to lose electron. So as the atomic size is increasing, as you are going down, these elements begin to have more ability to lose electron in their valence shell. Why? Because the electrons in their valence shell are not strongly attracted to the nucleus. Why? Because of what? Those what we call shell that prevent or protect the valence electron from getting to the center. Hence, the elements in oxygen family vary widely in their chemical properties. You need to understand that. So let's move. Here we want to talk about the bond in this particular case. So the bonding capacity of what? Oxygen. I've told you. So basically, you have two. The major achievement when it comes to electronic configuration is to obtain either duplet or what? Octet electronic configuration. So in this case, when you look at the what? The 6, you need 2 more electrons for it to obtain that 8. So what will you do? So it requires 2 more electrons to completely fill its what? Valence electron. In order to achieve this, it must gain what? 2 electrons. So when oxygen gains 2 electrons from the metal, it's from what we call ionic bond. As you have in what? Yes, N2 what? O. You have in what? Calcium O. So look at calcium, for example. Calcium is 20. Then you have 2, 8, 8, 2. So when you count that, that is 20. While the oxygen is 8, 2, 6. So it needs to lose 2 electrons to oxygen. So if it loses 2 electrons to oxygen, so what happens to calcium? Calcium becomes 2 plus because it has lost 2 electrons. So what happens to oxygen? Oxygen becomes 2 minus because it has gained 2 electrons. So when both of them exchange their valence electron, it becomes calcium 2, O2. Both can cancel out. Both 2 can cancel out to give you calcium oxide. So transferring of electron basically means, I hope you still remember in your chemical bonding, basically mean what? Ionic bonding. And good to know this. And aside these 2, it can share electron with other nonmetals to form what we call a covalent compound. And a good example is if you have O2, this oxygen, you have 2, 6. Then you have another one, 2, 6. So I need to do this. Let me just look for a way of cleaning what I've done here. Therefore, let me illustrate what I just said. So the oxygen 8. So in this case, you have 2, and you have what? You have 6. So we have another oxygen. So we have 1, 2, 3, 4, 5, 6. This is another oxygen. So what happened to this oxygen? It's going to pair. It's going to share the electron. So you have 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8 to form what we call a double bond. So when you look at it, it's a divalent element. A double bond exists between what? Oxygen molecules. And because it's sharing electron, it's called, what do we call it? Covalent bonding. It's called covalent what? Bonding. Yes. So oxygen with metal, it forms ionic bonding. With non-metal, it forms what we call a covalent bonding. Good. So how do we prepare oxygen in the what? In the laboratory. So we have to talk about how to prepare what? Oxygen in the laboratory. Then, to prepare oxygen in the laboratory, something is essential. The first thing that is essential is what are the reagents we use. So the first thing is hydrogen peroxide. Yes, oxygen can be prepared, yes, by what? Using a reagent called hydrogen peroxide with acidified KMNO4, which is potassium tetraoxomanganate 7 in the code. And what happened to the reaction? This is a redox reaction in which KMNO4 is an oxidizing agent and hydrogen peroxide is a reducing agent. And that's what you have here. So this is what you have here. Yeah, this is what you have. So in this case, you have K2SO4, you have MnSO4 to give water and produce what? Oxygen. You need to understand that H2O2, which is hydrogen peroxide, in this case, is a reducing agent. So what is it doing? It's reducing KMNO4 into K2SO4 and MnSO4. Then oxidizing what? Itself to what? O2 gas. Oxidizing itself to what? O2 gas. So it's very, very what? Essential to know that. The second one too, yes, by what we call catalytic decomposition of potassium triacylchlorate 5. And then KClO3 is heated. It involves heating with the what? And this is the reaction. You have 2 KClO3 is very important, must be heated. What is going on? To give KCl solid, yeah, these 2 plus 3 O2 gas. Then you need to know that this particular MnO2 is a what? Catalyst. Is a catalyst. It's very, very important. It is a catalyst that helps to catalyze what? KCl. Yeah, KClO3. You need to know that. And what is the catalyst doing? To speed up the rate of chemical reaction. That's very, very important. And the oxygen is collected over water. And that's what you are seeing here. So it's being heated. It's being heated. So if you are using potassium, so basically you need to understand that if you are using potassium triacylchlorate 5, you must remember that heat is what? Involved. And the catalyst called manganese what? 4 oxide is equally involved. So this manganese 4 oxide, what it's doing is to catalyze KClO3. And as a catalyst, it speeds up the rate of chemical reaction in order to produce what? O2. And that's what you have in this. Yeah, so heat is needed, unlike when you are producing oxygen for what? Hydrogen peroxide. Don't forget that we're talking about the laboratory preparation of what? Oxygen. Good. And then oxygen is being produced. And this collection is called upward delivery. Why is it upward delivery? I hope you remember, because the gas itself is lighter than air. It's not as heavier than air. So it can be collected over water and it's not extremely soluble in water. And what? By what we call upward delivery. Please, you need to know this. It's very essential. Good. So let's move to the next slide. Fine. The last method of preparing hydrogen from the laboratory is by what we call catalytic decomposition of hydrogen peroxide. Catalytic what? Decomposition of hydrogen peroxide. You remember, hydrogen peroxide, yes, oxygen can be gotten from what? Hydrogen peroxide. But in this case, we call it catalytic what? Decomposition of what? Hydrogen peroxide. And when it happens, hydrogen peroxide is reduced to oxygen gas and H2O is very, very important. Also, a catalyst is needed in this case, and the catalyst is manganese what? For oxide. And that's what you have here. The hydrogen peroxide goes straight to the what? To the round bottom flask that contains manganese for oxide. So when it happens, oxygen gas is being collected over water. So that is essential as well. Now, the industrial preparation of what? Oxygen. How can we prepare what? Oxygen industrially? You need to understand that, yes, oxygen can be gotten from the air because the volume of oxygen in air is about 21%. But not only oxygen is present in the air, nitrogen too is present in a very high volume, about 78%, and other elements. But the joy is they are all connected physically by physical means, meaning when they are separated, they can still retain their what? Properties. So with this, it's good for us that we can actually get oxygen from air. So how do we do that? Look at it, separating the gas from the air. As you saw, as you can see, yes, air is a mixture of what? Gases. I've told you. So what can we do then? How can we separate this gas? Should be a very big word. Yes, question that we need to answer. So to be just clever, what we can do, get the air. So when we get the air, liquefy it under pressure, turn it to liquid. When it turns into liquid, take it to the what? Fractional distillation what? Column. As you all know, fractional distillation column is very, very, very essential here. Why? Because those constituents have what we call a close boiling point. Aside that, they can easily be separated by physical means. So this liquefied mixture is taken into the what? Column. Fractionation what? Column. When you do that, so what happened? Let's see what happened. All this will be there. Yes, all this will be there. So in this case, the lesser component, or the component with what? Less boiling point, we need to evaporate first. They need to evaporate first when they get to their boiling point. As you can see here, you see this, see where the nitrogen is, and see where the what? Oxygen is. Basically, in this particular case, carbon dioxide will have gone, followed by this, the oxygen will just go before coming down to, the next one. So let me use this as an example for you. If this is 0, this 1, this 2, then this will be -1, this will be what? -2, meaning that -2 is less than -1. So in this particular case, the first one that will go with lesser boiling point is this. This will go, yes, followed by this, it will go, then followed by what? Nitrogen, it will go, then followed by what? Argon, yes, before this go. As you can see, the graph is going from the lesser to the what? From the lesser to the what? Higher boiling point. Since oxygen is what we need, when it gets to what? -183, oxygen is what? Evaporated, then condensed to be collected. You need to know this as well. Yes, industrial preparation is done by fractional distillation. I've already explained. So this is just the process. The air is cool under pressure, taken towards fractionation column, then gets heated, and the gas begin to evaporate. Fine. and this is the column, as I've explained before. So the air, so this is the liquefied air. So see the air, it enters under pressure, it gets liquefied. So the carbon dioxide and the water vapor are removed. So easy. You can use caustic soda to remove CO2, the water vapor. Yeah, for you to remove water vapor, you can use any drying agent to remove the water vapor. So the air compress, then cool, then pass here. On getting to this air, the air is expanded and it gets very cold after several hours cycling. So it liquefies. So the liquid air at what? Minus 200, taken to the what? To the column. So on getting to the column, what happened? I've told you, nitrogen go. So after the nitrogen has gone, the argon follow, then the oxygen is being collected. Then other components too are there depending on our choice. Okay, fine. So let's come to the what? Activities. What are we doing here? So what type of bonding do oxygen what undergo? Okay, what type of bonding does oxygen undergo? Is it ionic bonding, covalent bonding, or metallic bonding? Oxygen what? Molecules. I hope you know. So take a minute to digest this question. What's your answer? Oh, good. So what do you call it? Covalent. Okay. Somebody say covalent. So on that note, if you have said covalent, good, meaning you are good, wonderful, well done, fine. So the answer is what? Covalent. So on this note, I want to say thank you so much for listening.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Good. In case you have any question, suggestion, or comment, yeah, you can reach us on the what information displayed on the screen. Thank you, and bye for now.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.